I'm Mr. Precella. Today we're going to be solving rational and radical equations with our co-requisite college algebra classes. We're going to have a great time. I've already clicked on the media, which you don't have to watch, but you've got to click on it in order to see the problems. And to begin with, before we actually look at the first problem, I want to review something about fractions. A number divided by 0 is undefined. Okay? If there's a 0 in the bottom of the fraction, then that fraction is undefined. Sometimes students don't believe it until they see it on a calculator. It'll say error. We went 8 divided by 0, error, division by 0. Okay, let me quit that. What about, sometimes students say 0 over 0 is 1. Is it? What's 0 divided by 0? It's still an error. If the 0 is in the bottom of the fraction, then in general we say it's undefined. Now, why is that? Think about 8 divided by 2.
It's because you can't multiply by anything by 0 and get a number, because anything multiplied by 0 equals 0. And
yes, correct.
And that's why I think some people think like, oh, 0 divided by 0 is 1, because they're thinking like, oh, whatever you divide by itself equals to 1, except in the case of 0, because you can't multiply 0 by anything.
Yes, okay.
That is very well worded.
I wanted to make a point here. 8 divided by 2 is 4. What did you learn first? Division or multiplication? You learned multiplication first. 8 divided by 2 is defined to be 4 because 4 times 2 gives us 8. And realize that quotient is unique. There's only one answer. For 8 divided by 2, it is 4 and nothing else. You say 0 divided by 0. Well, anything times 0 will give you 0. The answer isn't unique.
See, 1 times 0 is 0, but there's nothing special about 1 if we had
50 million.
I'm going to write 15. 15 times 0. That would still give you 0. So, a number over 0 is undefined if it's a non-zero number. If you had something like 8 divided by 0, there's nothing that you can multiply by 0 to get 8. So there's no answer here. Whereas over here, there'd be infinitely many answers. 0 over 0, any number times 0 gives 0. So,
there's one other thing. N over O, no, that says no, you can't do it. Suppose you have 0 divided by a non-zero constant k. 0 divided by some number other than 0. What does that say? That says okay. It's okay to have a 0 up on top like that. That's equal to 0. 0 times k gives you 0. So N over O is undefined, but if you just have the 0 on top and nowhere else, that's okay. It's equal to 0.
Right. 0 divided by 5 is 0. If the 0's on top, the answer is 0. If you had $0 to divide them on 5 people, well, each person gets $0. Okay?
Now,
you just can't have the 0 on the bottom.
If we look at number 1, they're giving you some fractional equations. I said that a rational equation, rational is just another way of saying fraction. So a rational equation is the same thing as a fractional equation.
Let me write. I was pulling up the problem. So
I want to see the problems. Let's see. So looking at number 1. Number 1 and 2 are as easy as it's going to get today.
I think by problem 13, 14 are pretty easy.
Yeah, we'll see.
Okay.
Don't you just love it when we're saying, it's going to be
bad.
6 over 3x plus 1 minus 1 over x minus 5 is equal to 0. Maybe we better read the instructions. They want to know what values of the variable cannot possibly be solutions for the given equation. What values of x cannot possibly be solutions?
Without actually finding or solving the equation.
We see a fraction. I see two different fractions. We know that you can't have a 0 in the denominator. So whatever makes these two denominators equal to 0 could not possibly be solutions. So 3x plus 1 cannot equal 0. Notice I put a little equal with a slash through it. Do you do that?
Yes.
Okay. And x minus 5 cannot equal 0.
Now let's isolate each one of those x's.
So we're just going to solve it as if it were an equal sign. We want to get that x by itself, so what's the first thing we'll do? Minus the 1. We're moving the 1 over. So we get 3x equals negative 1. No, 3x cannot equal negative 1. And then to get rid of that 3, we divide by 3, I agree, to give us x cannot equal negative 1/3. So there's one of the numbers that x could not possibly be.
You add 5.
Add 5 here. So we're about to get the second value.
So it's x cannot equal 5.
X cannot equal 5. X cannot equal negative 1/3. So there are two solutions. Not solutions. These are not solutions, I should say. There are two answers. Thank you for pointing that out.
If you were actually going to solve the equation and you were just going to guess, don't guess 5 and don't guess negative 1/3.
These numbers absolutely cannot be solutions. Let's punch in the answer.
For years I didn't really like these problems because you're finding the numbers that can't possibly be solutions rather than the numbers that are solutions, but
No, scroll down a little bit. There. So the solutions cannot include negative 1/3, negative 1, oops, I'm not typing, negative 1/3, comma, I know I'm messing up, 5. What's going to happen here when I say check this answer?
It's going to say that's
Wrong.
Say
So
it's
Mark,
wrong.
put that comma outside of that denominator. Once you've typed that 3, either do a right arrow, that's what I do, just the right arrow on my keyboard, or you can click with your mouse, but either way,
Comma.
don't put the comma in, no, it's a positive
It's
5.
a positive 5? Okay. So what you're doing are finding the numbers that can't possibly be solutions. When we actually start solving the equations, if these numbers turned out to be the answer,
We'd have to mark them out.
we'd have to say no solution. So once we actually start solving equations, there will be an A and a B, and the part B will always be there's no solution.
There's something else I want to point out. Switch back to my paper here. Numerators can be anything. The things on top can be any sort of number. And you'll notice all they have here is just a 6 and a 1. Even if it had been a 6x plus 7 up there, you still wouldn't worry about that numerator. The only thing that determines when a fraction is undefined is the denominator. So it doesn't matter how messy the numerator is, a fraction is undefined when the denominator is 0. Any questions there? And number 2, I think, has the same instructions.
It looks a little worse though, but it's really not that bad a problem. Let me blow it up so y'all can see it easier.
1 over x minus 4 plus 1 over x plus 2. I don't know why they keep having just ones, numbers alone up on top.
It could be
It could be anything up there on top, okay? It doesn't just have to be a number. They could have a variable stuck on there.
So this one, you don't solve it.
Is that a plus? No, it's a minus. See?
Just what numbers can't be solutions. the first two fractions, it's pretty easy to figure out. Like the first fraction, what value of x would make that bottom 0? 4.
So x cannot equal 4. You're moving the negative 4 over, it became a positive 4. So there's one answer. The next one, x minus 2 can't be 0. So x cannot equal positive 2, I agree. Move it over, change the sign.
And now that third fraction. That one looks hard, doesn't it? Well,
X squared minus 2x minus 8 cannot equal 0.
Well, that's a quadratic equation with a slash through it.
So I think it's factorable. I think it's a simple trinomial. I don't think it's going to be that hard. X squared is just 1x times 1x. Now for 8, let's see, you can have 1 times 8 or 2 times 4. So we have x and x. Oops. Oh, damn. Oh, I mean, darn. X. X. Oh, I'm sorry about that. I don't know how it slipped out. What do we know about the signs inside here? One has to be negative, the other has to be a positive. Because it's a simple trinomial, we can look at the pair and pick out the one we want. They have to, in this case, because of that minus right there, they have to subtract to give us that number there. What do you think we're going to use? I think we're going to use a negative 2.
No, I agree with him.
A positive 2 and a negative 4? I was thinking it was going to give us the exact same thing here. Did I miscopy the problem? Make sure I didn't miscopy the problem. Oh my goodness.
Oh, wow.
Oh, look at that.
Oh, really?
Well, you know something? This is just an example. This is not number 2. This is an example like number 2, okay? Notice, I miscopied. That was supposed to be an x plus 2. We're just going to continue. No, we're just going to continue with the way it is.
So mark out 2 there and just write ex.
Yeah, this is just an example. You're right.
We'll do number 2 once you finish this one.
Okay, so x plus 2 cannot equal 0. That's going to give us x cannot equal negative 2. X minus 4 cannot equal 0, which says x cannot equal positive 4. So, hey, we'd already had a positive 4, didn't we? So, in this example here, where I miscopied, it turns out there are 3 numbers that can't be solutions. 4, 2, and negative 2.
But that's not number 2. Tim, I was going to do the next one, but you better do this one. Now do the real number 2.
Well,
just to show them that you can. Okay? Once you fall off that horse, you need to get right back up on it.
yeah. So let's make sure x minus 4 plus 1 over x plus. I made it a more rigorous problem in my mistake.
Actually, everyone's number 2, it's rigged really nicely. And you'll see that in a moment.
Switch. Make sure I didn't miscopy. So it's an x minus 4 and x plus 2. Yes.
Okay.
So here's the actual problem we were supposed to do. So x minus 4 can't equal 0. So x cannot equal positive 4.
This is familiar.
X plus 2 can't equal 0. So x cannot equal negative 2. and x squared minus 2x minus 8 can't equal 0. We'll factor it.
So it's basically the 2 equations.
Exactly. It's the first two every time. It's rigged to be
Minus
like that.
4 and plus 2 give us back that negative 2x. And notice we've already solved those. X minus 4 can't equal 0, so x can't equal 4. X plus 2, we've already done that one. So the only solutions are 4 and negative 2. Not solutions, the only answers. These are not solutions.
Oh, here. 4. 4 negative 2.
Yes.
Is that what you said? On everyone's number 2, it's always going to generate 3. If it's just the third denominator factors as the first 2. If I click similar question, can y'all look at this and tell me what answers I'm going to type on this one?
Positive 1, negative 4.
Okay, positive 1 and negative 4. This third fraction would factor as x minus 1, x plus 4. So it's not as bad as it looks. What you'll say, positive 1 and negative 4?
That seems super simple.
Okay.
The next question would be impossible.
Okay, let's see. I think we're going to do number. No, let's see.
Where are we
That's
here?
what happens with the
Not here.
equations in the numerator on one, and then the equations of the
The denominator.
denominator for the second one.
Do you mean the equation or the variable?
Oh, wait.
Well,
Let me-
it's 3x plus 6 over 3 minus 4x over
I think you're looking at an equation. That's what we're about to start doing. Now
Well,
we're
we're
not-
actually solving them. Here, the first two problems, again, I don't really like them because you're not finding the solutions. You're finding the two numbers that can't ever possibly be solutions. But, yes,
looking
don't
at number
like it.
3.
It says the solution set.
Is this like your number 3? I mean, were you looking at number 3? Okay.
You'll notice how I'm going to be spreading the stuff out as I write it out. Okay,
Write it real
2x plus 4 all over 2 minus, we have a 3x over x minus 2 is equal to x. Let's switch it up. Wait, let's make sure. 2x plus 4 over 2 minus 3x over x minus 2 is equal to x. Yes.
Do y'all remember the last time we had a problem with some fractions involving the quadratic formula, and we multiplied straight through by something to cancel out those fractions? That's what we're going to be doing here.
You're going to be trying to use the least common denominator. What I would do, look at the denominators that appear and ask yourself, can either of those be factored? This is just a number, so we're not going to factor that. What about x minus 2? No, that's just a binomial, a linear binomial. Notice there's no x squares. If you're going to factor something, the thing you're factoring is going to have, what? An exponent. There's no exponent there. If you have two distinct denominators, not repeated, two distinct denominators, the least common denominator is found just by multiplying the two denominators. You're going to have to multiply through and realize you're distributing. There are three terms. Fraction, the plus minus separates another term. Here, there's a second fraction. Moving over to the third, to the other side of the equal sign, you're picking up a third term. There are three terms, and you're going to have to multiply them by the least common denominator of 2 times x minus 2.
This is where it's going to get very messy.
Okay. We're going to multiply the first fraction by 2 times x minus 2. 2 times x minus 2. Hey, I don't see a denominator, so we assume that denominator is 1. Multiply the second fraction by 2 times x minus 2. This thing doesn't have a fraction. There's nothing to cancel there, so we're going to multiply it by 2 times x minus 2.
Our goal eventually is to get x equals some number.
But right now our goal is to get rid of those fractions. Look at this first one. We have a 2 in the denominator. We can cross cancel that with that 2 up there. So we have this 2 canceling with that 2. So we still have the binomial x minus 2 times, what have we got left at this fraction? The 2x plus 4, I agree. This minus right here, that minus is the minus I have right there. Oh, something nice is about to cancel in this second product. What's about to cancel? The x minus 2 here will cancel with that x minus 2. So we have a 2.
Why not just go ahead and multiply right now?
2 times 3x, that's 6x.
Now see if we always get into 6x. Notice it's really simplifying nicely.
2 times 3x gave us 6x. Now let's look here. We have an x times 2. Well, generally we put the coefficient in front. X times 2 is the same thing as what? 2 times x times the x minus 2. That's another thing we could have distributed there, but I think I'll wait to do that into 1 there. Wow, that looks messy. Look in here. Did it look that messy?
No, it looks bad. I'll tell you right now. Okay, continuing on.
We have to get rid of the parentheses. Remember, our ultimate goal is to get x equals. Look at this. X minus 2 times 2x plus 4. Binomial times binomial. What do we do? 4-letter word beginning with F. FOIL, here we go. First, x times 2x. 2x squared, I agree. Outer.
4x.
Okay.
Minus 4x.
Oh, that's nice. Negative 2 times a positive 2x, I agree with that. Minus 4x. And last, negative 2 times 4 gives us a minus 8.
I'd mark out those 4x minus 4x right now.
We have x minus 2 times the 2x plus 4. We FOILed that out. Notice the outer and inner terms. That's very nice. To me, this is such a messy problem. That's nice. Those x terms subtracted out. We still have this minus 6x equals, what are we going to do here?
Multiply 2x squared minus 4x.
Okay, so you're distributing the 2x times the x, 2x times the negative 2. 2x times x gives us a 2x squared. And 2x times a negative 2 gives us a
negative 4x. Oh, wow.
This is not nearly as bad as it could be.
Something nice is about to happen. At first glance, it looks like we have a quadratic equation. Remember, a quadratic equation is an equation, which means there's an equal sign, that has an x squared in it. But look, there's a 2x squared on each side.
Let's try to combine those x squares. If I wanted to take this 2x squared and move it over, what would I do to that positive 2x squared? Subtract, I agree. Minus 2x squared, minus 2x squared. We don't have any x squared terms remaining.
Maybe to make it look a little cleaner,
I'm going to
just write down what hasn't been crossed out.
I'm going to. All we have left there is, on the left side, we have a negative 8 minus 6x. What have we got left on the right? A negative 4x. I agree. This is a linear equation. It doesn't get much easier than this. We have to combine our x terms and then divide by the coefficient. I think the quickest way to get the x's on one side and the numbers on the other side. I'm not going to move this term over here, because if I do, then I got to move this 8 over there. That's what I'm going to do. I'm going to move that minus 6x over. That's good by adding 6x. Yes, it's still visible. Okay, so we have negative 8 is equal to negative 4x plus 6x gives me, okay.
Then you have to divide by 2 to make it negative 4 equals x.
And so equality is reflexive. I'm going to read it as x equals negative 4. There's one thing we need to check. Look back. Oh, it's hard to see the original problem, isn't it?
The original problem right here. So you can see the solutions, the options. You either have a solution, or it says the solution is the empty set.
If it's the empty, it would be the empty set if that number we found gave us a denominator of 0. Look back at the original problem. There's only one denominator that could possibly be 0, that one with the variable.
What number would make this denominator 0? The x minus 2? What would make it 0? If x were 2?
Did we get 2 as an answer?
What was our answer? Negative 4. So we just type in negative 4.
Negative 4 is a perfectly acceptable answer because it doesn't make that denominator equal to 0.
If we had gone through all of this effort and wound up with x equals 2, we'd have to say no solution. Or empty set, however they're wording it. So click here and type, was it negative 4?
Yes. Any questions there?
They're messy.
Because mine was a little bit messier than y'all's, because the numbers didn't, the middle numbers didn't equal out. It was like a positive 6 and a negative 9, and then minus the 12.
I'm surprised by that.
Mine got a little messy.
No.
I think the next problem isn't quite that messy.
Okay. We just did.
Yes, you're right. So you have a 6x, negative 3.
Make sure that you didn't miscopy the problem.
Oh gosh, it's too small to see. But,
When I look at this problem, when I look at number 4, I like the fact that it has the same denominator. It has the same denominator. If there's only one denominator, then that has to be the least common denominator. So the thing you're going to multiply 3 by is what? Let me write down this problem. The number 4. X over X minus 3. Let me switch over. Okay. Notice once again how I left all the space between the terms because I know I'm going to be multiplying by something.
Why is both the answer, I guess, there's two denominators of the same thing, x minus 3.
It's a repeated denominator. It's the same thing, so the least common denominator would just be whatever that denominator is. If you had just had a denominator of 5 and a denominator of 5, the least common denominator is 5. Repeated denominator, the thing you have to multiply by something to cancel out x minus 3. And what would cancel out x minus 3? Well, an x minus 3. So multiply by x minus 3, multiply by x minus 3, and multiply by x minus 3. Before we even go on, I probably should have asked y'all why the problem is it's so messy. Switch back to the, okay. What would be the only number that would be unacceptable as a solution? What's the only number? What would give us a denominator of 0?
Did I hear someone say 3? 3?
Positive 3?
Yeah, 3.
Oh, I did it here.
So if we wind up getting x equals 3, we're going to have to choose the no solution. Let me turn this on.
The empty set.
Empty set. Okay. So, but this one's actually less messy than the first one. Okay? Oops.
Now, before we go on, before I start canceling out, any questions on why I'm multiplying by x minus 3? I have to multiply by whatever it takes to cancel out this denominator and this denominator. And what would it take? It takes the x minus 3. If you have the same denominator, then necessarily that is the least common denominator.
Okay, start canceling.
I'm going to start canceling. The x minus 3 cancels with the x. Oh, wow, this is working out. Oh, this is really going to work out nice. What have we got here? When we cancel the x minus 3's, what are we going to be left with? X equals, when we cancel the x minus 3's here, what are we going to be left with? Just the 3. Oh, by the way, the 3 over 1 is just a 3, so I don't even show that.
That's not the x over 1 is an x.
Here there's no fraction, so nothing's going to cancel out. What are we going to do to multiply the 4 by the x minus 3? Starts with a d. Distribute, I agree. So that's going to become a plus 4x. And there, minus 12. Oh,
wow.
There's no quadratic. We're not going to have to try to get it set equal to 0 and factor. We need to get all the x terms on the same side. What do you think I'll do? Do you think I'm going to get the x terms on the left side or the right side? Yeah, I think it's quicker to move that 4x over to the left by doing what?
Not plus 4x to both sides. We're going to
minus 4x. I'll show that.
Remember that black x is actually 1x.
1x minus 4x. What are we going to have right here? Not 1 minus 4. No, 1 minus 4 is negative 3x. And look on the right side. We have 3 minus 12. That's negative 9. We want to get rid of that negative 3 in front of the x, so what will we do? Divide by negative 3. Oh no. Look what we're about to get. The negative 3 divided by negative 3 cancels. So we have x equals negative 9 divided by negative 3 gives me a... But wait a minute. What did we say that x could not equal? That denominator will be 0 if x is equal to 3. That denominator, the denominator can't equal 0. So x can't equal 3. We just got 3. So we have to cross that out. 3 is called an extraneous solution. You don't need to remember that terminology, but a solution that you get that doesn't check in the original problem, that gives you an undefined result, is said to be extraneous. Well, 3 is the only number that could have possibly been a solution.
So
that
what am I
means
going to choose here?
this equation has no solution, but they don't have the no solution option. They say the solution is the empty set. So I'll write that down, empty set.
I've already checked it.
If you're solving through these rational equations and the number you get gives you a denominator of 0 in the original problem, you have to cross it out. That's why we have those problems 1 and 2, to get into your head, denominator can't be 0. Any questions there?
All that effort to say this is, well, actually,
That's
all
a
that
big-
effort to show that there's no solution to
You
this
could sit
equation.
there, you could spend the rest of your life plugging in numbers for x in that problem, and the left side will never equal the right side. You could sit there, okay, I'm going to sit here for the next 40 years plugging in numbers. You will never get the left side equal to the right side. That would be a pretty sad existence, I must say.
What about this next one? I'll do it.
Oh, okay.
Oh, so we've said so far, if you have 2 completely different denominators, like problem 3, just use both of those denominators as the thing you multiply through by. If you have the exact same denominator appearing twice, just use that, multiply through by. Here, what if we have an x squared and an x? Let me
We have
write
the
that down.
same factors, x and x, in the denominators. The only difference is that there are powers on one of the factors. We have an x squared and we have an x. What would the least common denominator be here? People hear that word least and think, oh, we need the least exponent. Remember, you want to cancel out that entire denominator. If you just tried to multiply by x, okay, y'all are writing, but if you tried just to multiply by x, you're going to multiply the first fraction by x. Would you cancel out both of those x's in the denominator? No. So if you have repeated factors with different exponents, here the x is to the first power, this is the x squared. If you have repeated factors but with different exponents, use the larger exponent. So our least common denominator, the thing you're going to multiply through by, will be x squared, not x. And if you tried to just multiply by x, can you see you'd still have one x down there?
I'm going to try to show that.
Oh, okay, good.
If I just multiplied straight through by x, if I write x over 1, and right here just x,
would you cancel out the two x's in the bottom?
no, this red x would cancel with one of these black x's here, and we'd still have a denominator of x there. That's why if you have x squared and x, then always choose the larger exponent to multiply through by. So I'm going to multiply through by x squared. Now let me start crossing out. This x squared cancels with that one, leaving just that black 6 minus,
What's going to cancel here? X
just
and
an x. This black x cancels completely, but we still have one red x. I'm just marking out that square on it.
So what's the second product going to reduce to? 40x. Good.
Equals, well, just 14x squared.
Oh, this reminds me of a problem that we did on Thursday, because it's quadratic. We're going to have to try to solve. I will try to solve it by factoring. If we can't get it factored, we'll use the quadratic formula. But remember two things. If it's quadratic, you need it set equal to what number? You need a 0 on one side, and I want the number in front of x squared to be positive. So am I going to take this 14x squared and move it to the left, or am I going to move the other terms to the right?
Other terms to the right.
Yes, I'm going to get the 0 on... wait a minute, Tony, I was letting you do it. Why
That's
didn't
fine.
you say something?
Well, I'm just doing it just fine. So we're going to add the 40x and subtract the 6. So we have 0 equals 14x squared. And I'm going to write it in standard form. X squared, x constant. So I'm going to write the plus 40x next. And then what's my constant term? What am I about to write here? Minus 6. Are y'all caught up with me? Are there any questions? Now,
what we're about to do did not pop up in the last homework assignment, but it's an important trick. If you notice that there's a number that will divide into all the numbers there, you can shrink down the size of those coefficients.
do y'all agree that with factoring, the smaller the numbers are, the better? Would you rather be factoring something that had a 2 or something that had a 240 that you had to write out numbers that multiply together? What could I multiply straight through by that would get me slightly smaller numbers on all
I
of those?
always say, what can we divide by?
Oh, what did I say? Multiply? I meant divide. Oh, what can I divide by?
What number?
2. So I'm just going to go straight through dividing by 2. So we have a 7x squared. Is that going to be a 20x?
And
minus 3. I think those are going to be easier numbers to work with when we factor it.
because for 7, there's only one pair. 1 times 7. What about 3? Only one pair of factors. 1 times 3. So I agree, Tony. That's definitely going to be easier numbers.
I'm going to write my 2 sets of parentheses. And what about the signs? The second sign is minus, so plus minus, good. Now, 1x times 7x. How can I play around with that 1 and 3? How can I put them so that I'll get a 20x? Takes a lot of thought here.
If I put the 1 there, that's a 7x and a 3x. That's not giving me a 20x. So maybe try putting the 3. And once again, this is trial and error. We're just going through the possibilities in our head. And this is the sort of stuff those teachers at that conference years ago disliked, that I was telling you about. We have no control over what pops up here. And when we teach this class tomorrow, it's going to be a totally different they wanted to be able to do the same problems over and over. No. When we log on tomorrow, it's going to give us completely different
And that's your
numbers.
way of saying your numbers will be different from ours, and it's just luck of the draw. Yes.
Would be 7 minus 1 times x plus 3.
Okay.
I agree.
Yes. Did y'all hear that? You're making a positive 3, so you have a positive 21 minus 1.
No. Oh, yeah. Yes.
21x minus 1x
yeah.
is a positive 20x.
I looked up here and saw a plus 3x. I don't know why. I think it was that 3 there. But okay.
So set back to the 0. I'll set the x plus 3 to 0 and isolate the x by moving that 3 over. And then I'll set the 7x minus 1 to 0. That's going to be a little bit more involved. What do I do to get that? x by itself, I would. Are y'all caught up with me? How am I going to isolate the x here? Yeah,
yet.
but first I'm going to remove the 1. I think it's easier to do the adding and subtracting before the division. So I'll have a 1 on the right, then divide by 7. Is that what I heard? So we have, I'll circle these answers. -3 and 1/7.
Oh, wait a minute. Let's look back and make sure those numbers are okay. We had a fraction to start off with, didn't
Show
we?
the problem as it's written there.
Here it is. What number would make those denominators 0? It should be obvious. What
But through
number?
the 40 over x, what value of x would make that 0?
0?
0? Yeah.
Did we get 0 as an answer? 0 is the only number that would be unacceptable. Did we get a 0?
Nope.
Nope. We got a -3 and a +1/7. So both of these answers are okay. Any questions before I type those answers in? Okay, -3 and +1/7. -3 and +1/7. Any questions? Yes. Did what backwards? Oh, the order of the factors doesn't matter. So, okay, that is just as right as what we wrote, okay? He wrote the 7x minus 1 in the front parentheses, the x plus 3 in the back parentheses.
But he's still got a 1/7 and a -3 as the
And
answer.
the order that you write in it just doesn't matter either, okay? So that is just as correct as what we have up here.
Any other questions? Uh-huh.
So the final solution is 0, and that solution is set.
Yes, if our final solution had turned out to be 0, because 0 squared would give you a 0 there,
Six,
or just
seven.
0. But it didn't.
And then if we get the same denominator that we started off with, that also would be an
Oh,
No,
that's just a coincidence that worked out like that, okay? It doesn't mean if you always have the same denominator, it'll be empty set. The reason, go back to number 4, was it?
Yes.
The reason this was an empty set was because we got x equals 3 when we went through. And so, I think everyone's number 4 will be empty set, but it's not really because
Mine is.
that's the same thing. It's these other numbers.
They've rigged these things. This 3, if this had been a 5 instead of a 3, or a 2 instead of a 3, it would not have been an empty set because you wouldn't have gotten 3. They have it rigged here so that problem number 4, every time you do it, you get whatever that number is that gives you a denominator of 0.
But there's no rule in algebra, if the same denominator appears twice, it's an empty set. But for your problem 4.
But don't rely on the fact that your problem 4 is going to be it's going to be an empty set and then just go on, because on the actual test, all this stuff is going to be shuffled up. The problems,
It won't be number 4 on the test. Okay? But now, another question.
number.
I think we're up to number 6.
Oh,
You want to do that?
okay.
I like this. This is a special type of problem where it says fraction equals fraction. And we're going to have a lot of equations like that this semester. And so when there's a fraction equal to a fraction, what I prefer to do is cross multiply. And it only works, this cross multiplying only works when it's one fraction equals one fraction. If you look at problems 3, 4, 5, and you ask yourself, well, why didn't he do that there? It's not one fraction equals one fraction. On problem number 6, This is how I prefer to do. One fraction equals one fraction. But by the way, what's the one number we can't have as a solution? Well, we'll put a 0 down here in this fraction.
No, 2 wouldn't give you a 0. If you put a 2 in for x, you'd have a 2 there. So what number would give us a denominator of 0? It should be obvious.
If it's just a plain x.
No.
0.
Switch it.
Like,
Switch it. Remember how we were determining the unacceptable answers in problems 1 and 2. You take, well, this denominator here, there's no variable. It's going to stay at 2 forever, okay? But this denominator, you can't allow that denominator to be 0. So what number can x not equal? There's not anything to solve for. You already have the x by itself. X cannot equal 0. If you plugged in a 0, you'd get negative 7 over 0, undefined. So we're going to cross this cross multiplication. If you wanted to multiply by the least common denominator, you have two distinct denominators, so you multiply by 2x. You'll still get the same thing that you will when you cross multiply, but I just want to remind you all of cross multiplication. You take the 2x minus 7 times 2. You have a 2x minus 7 times 2. I'm going to put that 2 in front of it because that's generally how we write it. If there's a monomial, just a single term factor, that usually goes in front. And then I'm going to multiply here. So I'll have x minus 5 being multiplied by x.
I will normally not show that step in the future when we're doing these. I'll just distribute, okay. Go straight to that distribute step. When we're doing nonlinear inequalities in a few days, we'll be doing quite a bit of this cross multiplying.
So let's distribute the 2. What's that going to give me? Here and here. I'm waiting. 4x minus 14, yes. Here, distributing the x. Okay, I did it. I put it here, you?
5x.
He said
X squared minus 5x.
X squared minus 5x. I agree. X times x gave me the x squared. X times a negative 5 gave me the minus 5x. Uh-oh, this is quadratic. That means we need 0 on one side. And I want that number in front of x squared to be positive. So where do you think I'm going to get the 0? Am I going to get the 0 on the left or on the right? I agree. Get it on the left. We'll have a 0 here. A 0 here. We already have an x squared. We have that minus 5x. We're going to move those over. So that's going to give us a minus 4x. And what else will we have?
Positive 14.
I agree. Any questions there? And then we can combine these middle terms. Look at that. Negative 5x minus 4x. That's going to give me an x squared here. Negative 5x minus 4x is?
Negative 9x.
Negative 9x. I agree. And I still have a...
Positive 14.
Finally, we have something to factor, and I like the fact that that last sign is a plus.
I also like the fact it's just an x squared,
Yeah.
not a number in front of that x squared.
Mm-hmm.
So draw your, well, I guess you can write out the numbers that multiply together to get 14.
Oh.
I suspect,
Negative 2 and negative
Well,
Yeah.
14 is 1 times 14, or 2 times 7. X squared, there's only one possibility, x and x. The second sign's a plus, so you don't have to wait. You know that you're going to have 2 of the first signs. And what did you say we'd use, 1 and 14 or 2 and 7?
2 and 7.
I agree with 2 and 7.
So it means it would be positive 2 comma
Okay, now,
right.
first of all, notice the outer product is a negative 7x minus 2x. That gives us back that negative 9x. And then you say x minus 2 equals 0. X minus 7 equals 0. So what did he say here?
Positive 2. He said positive 2.
Right,
And a
okay.
positive 7. This is an example of you being able to do steps in your head and get that answer without writing down everything that we're showing here. But again, our goal is to try to show our thought process.
If not show, communicate our thought process.
Well, you're showing it by writing it down there. Any questions on that? We didn't get a 0 as the answer, so it's not going to be empty set or no solution. We're just punching 2 and 7. 2, comma, 7. Okay.
Y'all want to take a break because we still have to do radical equations, or do you want to just keep on working through?
Keep on working through.
What do you want to do? Go ahead. Question. Oh, okay. Well,
You want to start the square root equations?
now I want to look. Okay, we're looking at radical equations.
And radical equations are equations that have square roots or cube roots. Oh, we.
Hold on, leave him.
Oh.
No thanks.
Well,
This is problem 9.
Get ready for problem 1.
I think number 9 is a really good example for to introduce these things. Okay?
fractions are not always defined. They're undefined when the denominator is equal to 0. Square roots aren't always defined either. If you're only looking at square roots, not cube roots, but square roots, you have to realize that
we're not interested in negative or imaginary numbers any longer. At the beginning of the semester we said, square root of a negative is an imaginary number, but I'll do this one.
Before we go on, I want to point out something. Can you switch?
Oh.
There is a problem with how we're going to solve square root equations, okay? We're going to have to be checking our answers as we go through with square root equations, and I'll tell you why. The approach will be, if you want to get rid of a square root, you square both sides, okay? It goes back to that square root of a times the square root of a equals a. But let's see, I think that as long as we have the square here, I think you'll agree that's a true statement. 3 squared is 9. Negative 3 times negative 3 is also 9, right? So as long as you have those squares, that's a true statement. Suppose we don't have the squares. Suppose those squares aren't there. Is this still a true statement? No, there isn't. When you raise both sides of an equation to an even power, you're squaring. That 2 is an even number. You run the possibility of taking something that's negative and squaring it and making it positive. So, for square root equations, you're going to have to check answers, but don't panic. Tony has a real good way to get through the checking.
I'll just plug it into a calculator.
Oh, is that it? Okay, square root equations, you're going to have to check your solutions. There are some patterns that you can use. Okay. And I think Tony will take over.
I'm going to write one of my sentences.
Uh-oh. You and those sentences.
Okay.
The sentences help.
To solve a radical equation, that's an equation that has a square root or even a cube root, isolate the radical term. So, to demonstrate what I mean by that, look at that problem number 9. First thing we're going to have to do is get that big square root symbol by itself.
Hey, there's a -6 there.
So
What are we going to have to do to get rid of that -6 on the left side?
Okay.
Okay, so that's what he means. Now, if there's more than one radical, you have to isolate a radical. Maybe you'll isolate them both at the same time, but
Well, then,
wait. Okay, so going back to your sentence there.
then sentences. Then raise both sides of the equation to the same power as the root. So if it's a square root, you square both sides. If it's a cube root, you cube both sides. Okay?
I prefer cube roots. Cube roots get a bad rap.
Yeah.
People don't like cube roots, but if you have a cube root, you're going to have to cube both sides. Now, that's an odd power. 3, a cube is an odd power. You only have to check, it's the even exponents that mess up things. Those are the ones where you have to check your work. If it's an odd root, like a cube root, once you're through, that's it. You don't have to worry about checking your answers.
Okay, so after you raise both sides, solve the resulting equation, check your answer. Basically when you have a square root, but I'm going to say when you have an even root. Even would be 2, 4, 6,
so
7.
fancy. Let's say, I would have said, check your answer when you raise both sides to an even power.
Oh, okay. Well, I can just look at the problem, and if it's a square root or a 4th root or 6th root, I'd say you have to check it. Okay? It sounds much worse than it is, but number 9. No. Oh. Well. Wait,
Now,
let me leave this
so I
up
guess
here
we
for them to
decided we're
write
not
more.
taking a break, okay? And so, but if you need to step out, you just step out and just, go right on out if you need to step out, or if you have to leave now.
Tim,
Have
I
you
was,
written the
I was
problem
waiting
down?
for them to, in case they,
Oh.
have y'all finished writing down my sentence that
Yes.
Tim removed? The
Yeah.
sentences?
You
I'll
know
be
what I
flipping
would
back
do,
and
Tony?
forth.
You know what I would do? I'd number. Okay, to solve it, isolate the radical term, then raise both sides of the equation to the same power as the root. 3, solve the resulting equation. 4, check your answer if you have an even root. Now, now I'll write down number 9. The square root of 5x plus 44, then a -6 equals 3x minus 2. Notice that 44, these numbers might get kind of large here. So, if you wind up those people that were,
with a 20 instead of a 2 right here, then, oh wow, you're unlucky today, okay? But we have no control over it. So first thing you do, add 6 to both sides to get that radical term by itself. So we have square root of 5x plus 44 equals, what's that going to be? -2 plus 6 is that 4? Now here's where it's going to get messy, and this is why square roots work out messier than cube roots. I'm now going to cancel out the square root by squaring. When I do that, I enclose both sides in parentheses and Tim, put it back. Oh, wow. Okay. So I've added 6 to both sides. That's where I got the 4. Now I'm squaring both sides by enclosing both sides in parentheses and squaring. And the left-hand side is going to simplify really easily. A square root and a square cancel each other out.
This is something from the first day of the semester.
Oh. Square root times square root, or if you wrote the square root times itself as a square root and a square cancel each other out. We'll be using that off and on all semester. So there. On the left-hand side, all I have is 5x plus 44. But that right-hand side, 44. You don't, to square this 3x plus 4, you're not just going to square the 3x and square the 4.
I remember a problem about this with imaginary complex numbers.
So you had to put it as like a double and
Yeah,
FOIL it?
exactly. Did y'all hear that? For this 3x plus 4, you got to write it twice and FOIL it out. So foiling it out, we'd have a, is that a 9x squared?
9x squared plus 12x plus 12x plus 16.
Oh, did that fast. So we have 9x squared plus 12x plus another 12x plus 16. Oh, wow. I'm going to go ahead and add that 12x plus 12x and write it as 24x.
Which side do you think I'd get the 0 on? Okay. We want it's quadratic, so it has to be set equal to 0, whether you're factoring or using the quadratic formula, and you want that leading coefficient, the number in front of x squared, to be positive. So I agree.
So I'm going to subtract 5x from both sides, and I'm also going to subtract 44. So on the right, on the left I have a 0, and on the right,
9x squared plus 19x minus 28.
but 19x squared plus 19x minus 28. Oh. I'm going to try to factor it. This might be one of those, you want to just use the quadratic formula. Quadratic formula always works, but I think every problem in this assignment factors. So numbers that multiply together to give 9, 1 times 9, 3 times 3. Numbers that multiply together to give 28. But there's also 1 times 28, 2 times 14, and 4 and 7. Is that the last pair?
Okay. Do you see it? Tony, do you see it? I've
Yeah.
spotted something about the numbers.
Yeah, I've spotted it. Oh, gosh. If I try to, let me see. First, I'll draw my two sets of parentheses. Second sign is minus, so plus and a minus. And here it's a matter of, there's something that's sort of staring in your face, and if you realize it, okay, we want the outer and inner to subtract to get this middle term. And what Tim saw and what I've seen is, if I subtract 28 and 9, don't I get 19? So I'm thinking, let's see if we can make it work with those two. Use the 1 and 9 and the 1 and 28. What made me decide on that? Well, I noticed, we can subtract the 28 and 9 and get a 19, which is that middle term. So,
But at the same time, the other thing I noticed, I tried the 3 and 3 and 4 and 7 in my head, and I saw that didn't work as I looked back at the problem. And that's when I spotted that 28 minus 9 gives 19.
if I'm going to make this work out,
You want to put the 28 here, 28 times 9. Isn't that going to give you some huge number?
If I put the 28 here, I'm thinking it's not going to work out. Okay? So I'm going to try it like this. The 1 and 28. Let's see.
I think that's going to
Inner would be 9x. This outer, 28x. If I want a positive 19x, well, I can subtract the 9 and 28 and get a 19. So how do I need to arrange the plus and the minus?
Minus 1 plus 28.
Okay, like that. So we'd have a negative 9x and a plus 28x. I'm agreeing with that. It's a matter of how fast you notice that. Okay? On tests, well, you know, at least on tests there's no time limit. Okay?
Bless you.
Okay?
Everybody's
Yes,
sneezing
it might be
It's
allergies.
allergies.
All this rain, everything is growing. And
This
so
is
forth.
like we're experiencing because of all the rain. It's like April. The trees, grass pollen is out of control. All the trees are blooming. That shouldn't be. It's all that rain. So
Okay, I'm going to have to move up. Okay. Okay. Isolate the x by adding 1. So we get x equals 1. And this one's going to be an ugly fraction, isn't it? What would we get?
Negative 28 divided by 9.
9x is negative 28. Divide by 9, so negative 28 over 9. And, so let me reread through this. We isolated the radical term. That's what we were doing when we added 6. We raised both sides to a square because it was a square root. And we went through solving the resulting equations. Check your answer when you have an even root, mainly a square root. For your purposes, if it's a square root, you have to check it. If it's anything other thing like a cube root, you don't. Y'all see which one of these numbers do you think will be easy to plug in and check?
1.
Yeah, the 1. I'm now going to check this. And by checking, I mean we got to plug it into the original statement of the problem. Put a 1 in place of this black X here and right here. And we'll see if we get the exact same thing on both sides of the equation. You know what you might want to do? Pull up your old calculator.
You will be able to get this right.
Mm-hmm.
Because if
Yep.
you replace the x in the square root of 5x plus 44, you will get the square root of 49, which will equal 7 minus 6, so that's 1. Placing 1 for the other x, for the 3, will be 3 minus 2, which is 1.
Okay. Did y'all hear all of that? I'm plugging a 1 in. 5 times x, so 5 times 1 plus 44. So that's going to be a 49 under the square root symbol. And the square root of 49 is 7. Subtract 6. So on the left, we're getting, let me check. I'm going to make a note. Use calculator. So it's 5 times a 1 plus 44 and then a minus 6. That's 49 under the square root. The square root of 49 is 7. So we're getting a 1 on the left-hand side. Now let's do the same thing. Let's look at the right-hand side and ask ourselves, are we getting a 1 there? Well, this is a little bit easier to do. You might not even need a calculator with it. If you put a 1 right here, remember the semester the student would answer the question, plugging in a 129. And it took me a while to figure out what the heck he was doing. If I plug a 1 in for this x, how would you get a 29, which is the wrong answer, by the way?
31 minus 2.
I was like, oh my, when it finally dawned on me, how is he getting these numbers that he's calling out so confidently? He wasn't multiplying 3 times 1. He put a 1 there and got a 31. You see 31 minus 2, 29. But we multiply. 3 times 1 is 3, minus 2. So yeah, the positive 1 checks. So I'm going to enter that number. But it's this other one here. This negative 28 over 9.
Negative, think of it as a mixed number. Let's think of it as a mixed number.
Oh, I don't think that'll make it easier to plug in.
That's like a 3, right? A negative 3?
Negative 28 divided by 9 is a little more than 3.
That doesn't help. And I was hoping it would give us an imaginary number under there.
So I'm just going to, I'm punching into this sort of calculator. If you have the Calc 84 calculator on your phone, I think it's easier to plug it in then, okay, than in here. But okay, the square root of 5, I'm plugging a negative 28 over 9 in for x, so I'm going to put it in parentheses. 28 over 9, close parentheses, plus 44. And I'm going to go ahead and say enter on that, and then subtract the 6. So I'll put a 28 over 9, negative 28 over 9, in place of this x. So I'm getting on the left-hand side, when we plug into your calculator, let me make a note. Plug negative 28 over 9 into calculator. On the left-hand side, we get a negative 0.66666. Now, I'm not going to write all those digits. Now let's plug it into the right-hand side. In place of this x, put a negative 28 over 9. There's not a lot of these with this messy checking.
3 negative 28 over 9. And then we have what, a minus 2. Are we going to get the same thing, that negative 0.666? What do y'all think?
No, we're not. So this fraction, negative 28 over 9, doesn't check. What did we get there? Negative 11.333. Okay. Y'all sort of see why I'm crossing out the negative 28 over 9. This is some of that messy stuff that I tried to warn you about, but I think the next assignment will be a little better, so just bear with us. Thursday will be better than Tuesday. This is some of the messy stuff. So the only answer that you plug in is a 1. So, come over here. Plug in 1.
Any questions there? There's a lot to absorb there.
This one is about the most involved question it is the most involved problem you're going to see in this assignment. Probably even counting the next one. Oh, I can't see.
I want to do something. Before we go on from number 9, I want to do something. Be honest. When you got right here, 9x squared plus 19x minus 28 equals 0. How many of y'all would have just used the quadratic formula rather than trying to find it? You could have. If you'd used the quadratic formula, you would have still gotten a 1 and a negative 28 over 9. And so, since I think I want to take the time, I'm going to solve that equation using the quadratic formula. Do we have time for it? I think we do.
I do. I think we have time. So,
9x squared plus 19x minus 28 is equal to 0. Do y'all see what I'm doing? Because I'm thinking factoring this one would have been sort of difficult. Am I right? Would you have used factoring, or would you have gone to the quadratic formula? Quadratic formula. Let me write this down. It's also good to do this just because I don't think any of the quadratic formula problems had A, B's, and C's like 9, 19, and 28. They seem to have smaller numbers. Let's identify our A, B, and C. A is equal to 9. B is equal to 19. And C is equal to... And recall the quadratic formula. And okay, negative b, the opposite of positive 19, what are we going to have right here?
Negative 19.
B squared. You take 19 times 19, that's going to give you
361.
Minus 4 times A times C. A is 9. C is a negative 28. All over 2 times A. 2 times 9. What 18. And let's work underneath that radical. Punching that into our calculator.
Minus 4 times 9 times a negative 28 under that square root. We have a 1369.
And look at 1369. Don't panic. Take the square root of that number.
1369, a perfect square. Yes, sir. It's a 37.
This didn't happen with the quadratic formula problems the last time. If you could get if that number under the radical is a perfect square, then it could be solved by factoring. But we're solving by the quadratic formula. So we have negative 19. The square root of 1369 was 37 all over 18. And let's not leave it like that. We can separate and get two distinct answers. We have the plus and the minus option. We have negative 19 plus 37 all over 18. Well, negative 19 plus 37, isn't that a positive 18? 18 over 18, what is that going to give us? 18 divided by 18. 1. Isn't that what Tony got when he was factoring? That's one of them right there. 1. Let's do the other one. The other option is that minus. Negative 19 minus 37. All over 18. Negative 19 minus 37, is that a negative 56 over 18? Hey, let's cancel above and below. There's a common factor of 2. Negative 56 divided by 2 is a negative 28. 18 divided by 2 gives us a positive 9. So if you can't solve the equation by factoring, or if you don't see the factorization, you can still get the solutions using the quadratic formula.
And then you still got to check it, and you mark
Then
out
marking
that.
that out.
Okay.
I just wanted to point that out to you, that if your factoring skills aren't that strong, or if you just don't see the correct factorization, you can still solve the equation using the quadratic formula.
Especially if you're winding up with some big numbers, and it looks like yours is pretty big over there. Okay. After class, I'll look through it and see if there's everything's correct on those calculations.
Well, maybe there's a common factor that can be
I
canceled.
didn't see it.
Okay.
How about problem number 10?
It has to be easier than number 9.
Number 9 is the worst.
Okay, number 10. Okay. We have the square root of 6x, and we have a minus x. Oh, this is a lot better. At least there are fewer symbols and terms to write down. Oh. Remember the sentences my brother wrote out. To solve a radical equation, you first isolate the radical term. Then you're going to raise both sides to the power. So, we have to isolate the radical term. So we need that square root of 6x by itself. We're going to have to move these terms over, aren't we? So we'll have a square root of 6x equals, what are we going to have over here? That minus x is going to become a positive x. That plus 12. Okay. And it's a square root. So we square both sides. Square. Square. The left side works out nicely.
Yes. Oh, did I miscopy it? Or did he miscopy it? Let's see.
I might have.
It's a square root of 6x,
A minus
and then a
x
minus x,
plus
and a
12.
plus 12.
No, I got it right. If you think I've miscopied a problem, you call out. Don't let me get through with it and then,
Well, the left-hand side cancels nicely. The square root and the square just cancel out.
giving us a 6x. What are we going to have to do here? Squaring that x minus 12. Write it twice and FOIL it out. First,
X squared
outer,
12x minus
inner,
12x
last.
144.
Negative 12 times negative 12, I agree, that's a 144. And
You can technically add the two negatives, so the x squared minus 24x.
negative 12x minus 12x, I agree, is a negative 24x. And we still have that plus 144. It's quadratic, so you need it set equal to 0. So, where do you think I'm going to get the 0? On the left side or the right side? Left side, I agree. Subtract 6x. Subtract 6x. Let's get...
X squared minus 30x plus 144.
Okay.
Well,
And...
oh gosh, 12 times 12 will give us 144, but
that's not going to give us that minus 30x. So what
let's
do...
see. So, second sign is plus, so 2 with the first. Why don't you write the XX and the minus minus 2?
Oh, that's a nice... The second sign's a plus, so you have 2 of the first signs. Minus, minus, and x squared, that's x times x. And let's see.
And rather than using the quadratic formula on this, I think I'm going to just think, okay, 12 times 12, that doesn't do it. You can't add 12 and 12 and get a 30. So let's see, what other numbers?
1
Divide it into
24 times 6.
24 times 6.
That should do it.
Oh, yeah, 24 times 6.
And that'll give us that minus 30x. And if you check the inner and outer, that's a negative 24x. And right there, that's the negative 6x. Negative 24x minus 6x gives us a negative 30x. Is that what we needed?
Yep.
Yes, it is.
So everyone's number 10 is going to seem a little bit less intimidating than number 9.
Set each factor equal to 0 to give us.
X equals 24 and x equals 6.
Now, this one will be easier to track.
Here's what I'm going to do. You have to check in the equation that has the square root. But I believe it's quicker if you use the equation that's already been isolated. The way you move that square root of 6x, use the modified one. Okay, you can use the original one, but look if we use the one for the square root that's by itself. Here it is. The square root of 6x equals an x minus 12. Okay. Y'all see where I got that? It's the original equation when I move those two terms over. I don't see a sign here in front of this square root. If you don't see a sign, what sign has to be sitting there? If something doesn't have a sign, what do you assume, positive or negative? Positive. 6 can't possibly work. If you plug in 6, if you check x equals 6, 6 minus 12, that's a negative 6. It can't possibly equal a positive number. So
Plug in a 6, you would get a 36 under that square root, and the square root of 36 is a positive 6.
Not a negative
Not
6.
a negative. So mark out that 6.
Now for 24, checking 24, we have a square root of 6 times 24, that's 144. Plug in the 24 there, 24 minus 12. Is this a true statement? The square root of 144 is, the square root of 144 is 12. Does that equal 24 minus 12?
12.
Yes, it does. So the only acceptable answer is 24.
So I'll plug in a 24. Any questions there?
Cube roots get a bad rap. People don't like cube roots, and it's a mystery to me why. Cube roots don't generate imaginary numbers. You don't have to worry about cubing something that's negative and it becoming positive. If you take a negative number and you cube it, it stays in negative. Cube roots are not as bad as people think they are. And with that in mind, number 11.
The problems sort of
Get easy now.
okay. So square root equations that are really, really messy. Does that mean everything from now on is going to be as messy as that? No. Just got to muddle through those square root equations.
Oh, go wait.
Make sure you wrote it. Cube root of 3x plus 4, then another plus 4 equals 1. Okay?
Remember Tony's steps. We're going to isolate the radical, Raise both sides to the power. And instead of squaring on this one, what are we going to do? Instead of squaring, we're going to cube it, okay? Solve the equation. You don't have to check your work here, because taking a negative number and raising it to an odd power doesn't give you a positive result. You only have to check your answers if you're raising it to an even power. So with that in mind,
Basically square root.
square roots, that's what we're concerned with. So with that in mind, there's only one correct first step. What is it? Okay, good. Get that 4 over on the right. You have to isolate the radical, and that's going to give us
Negative 3.
Cube root of 3x plus 4.
1 minus 4, I agree, with negative 3. We have the radical isolated, so it's time to cube both sides. Oh, that green is hard to focus on. Here.
Oh, yeah, that makes it better. By better, I mean blurrier.
What have we got on the left side?
3x plus 4.
Okay, the cube and the cube root cancel each other out. I agree with the 3x plus 4. Now on
Don't
the
say negative 9. Write it out.
negative 3 times negative 3 times negative 3.
So it's negative 27.
That's
Right here
correct.
is negative 27. Negative 3 times negative 3 is positive 9 times another negative 3 is negative 27. Is this the easiest problem we've done today?
Yeah.
I think it is.
We don't have a square. We don't have to factor.
You add
Well-
27 to both sides.
I'm not going to add 27 to both sides.
Theoretically, there wouldn't be anything wrong with that, but
Then you'd have to get the constant by
this is
itself.
a
so-
linear equation, so we don't need a 0. We just want the x by itself.
So what can we do to get the x by itself? We've got to get rid of the plus 4 and that times 3.
Minus 4.
Yeah.
Minus 4, I agree.
Theoretically, you could have added the 27 and then subtracted the 31, but you're doing one extra step.
Negative 27 minus 4 is a negative 31. And then
Divide by 3.
divide by 3.
Equals negative 3 over 3.
So we have x equals negative 31 over 3. And look what I'm doing. I'm just boxing that answer in. I don't have to check my answers. I don't have to check my answers because that was an odd power. Raising both sides. I remember we used to have a textbook that used the terminology equivalence. Raising both sides of an equation to an odd power guarantees equivalence. Raising both sides of an equation to an even power does not guarantee equivalence. If you raise both sides to an even power, you got to check your answers. But if you raise them to an odd power, you don't have to. You can if you want to. If you just have spare time and you want to plug it in and check, go for it. But it's not necessary.
Any questions on that one? I want y'all to see that it's not all problem 9 and number 9 was the worst. Okay?
Okay.
Let's see. What
It's
about
like the third power.
It is a third power, isn't it?
No, a 1/3.
Oh wait, we'll
Oh,
get to that.
that.
That's number 14, isn't it? Okay. So we're going to do number 12 first. Because I claim number 14 is easier than number 12. And number 12 isn't that bad either. But,
We just have to define what they mean
I
by
know.
a fractional exponent. The cube root of 5x squared plus 3x minus 4 minus the cube root of 4x is equal to 0. Make sure I didn't miscopy it. Okay.
Well, there's two radical terms. So my little sentences said isolate the radical term. Well, if there's two of them, just put one on each side. Which one do you think we should move over where that 0 is? Yeah.
Because that'll get rid of that negative, and it'll just become a positive cube root of 4x. So we'll have the cube root of 5x squared plus 3x minus 4 equals the cube root of 4x. And then the one time that they want to get in here and fix that projector, our class is taking long. So we cube both sides. What's going to happen on the left side? Okay, leaving us just that 5x squared plus 3x minus 4. And on the right side, okay. So at first glance, this problem looked bad, but in reality, we were able to get rid of those radicals pretty easily. It's a quadratic equation, so we need 0 on one side. Do you think I'll get the 0 on the left or on the right? On the right side, I agree. I want that 5x squared to stay a positive 5x squared. So we have a positive 5x squared plus 3x. No, it isn't. Well, I'll just write out the minus 4x. And we have that minus 4 equals 0. So what's that going to give us? A 5x squared. 3x minus 4x gives us a negative 1x. Minus 4 is equal to 0. And this thing is factorable.
1 times 5, 1 times 4, 2 times 2.
1 times 5, 1 times 4, and 2 times 2. And I'll write my two sets of parentheses. Go on up.
Second sign is minus.
That means we're going to have one of each sign. It could end up being a...
5x plus 4.
Okay, you're thinking, okay, use the 1 and 4. Because why?
5 minus 4 gives us 1. So don't use the 2 and 2. If you try the 2 and 2, you're going to wind up with a 10x and a 2x. That's not going to give you a minus 1x. So we're playing it out in our head. Here's another question. Am I going to put the 4 here or the 1 here?
The minus 1 there and on the other side positive 4.
Minus 1 there and a positive 4 there. Let's check and see. We're going to check inner and outer. The inner is a negative 5x. What's the outer product?
Positive 4x.
Negative 5x plus 4x gives us a negative 1x. Is that what we needed?
Yes.
Yes, it is.
I want to mention something that a student asked yesterday, and oh wow, I wish I'd... When we were factoring last week, I said that you can't have common factors in the parentheses other than 1. And then I said there can't be like 2 even numbers in the same set of parentheses. Then I went as far as to say there can't be 2 of the same numbers in parentheses. And that student yesterday was asking me, what about something like this? It's a 1x and a 1. It's the same number. And I was like, other than 1. I should have said that. You can't have the same number in parentheses other than 1. Okay?
Set each factor equal to 0 to give us here x equals
1.
Okay. And
Notice
notice
we
I
don't have to check
don't
it.
have to check. It's an odd power. The other one, 5x plus 4. Set that equal to 0. What will I do first to solve this?
minus 4
minus the 4 to give us 5x equals,
negative 4, then divided by 5 for x equals negative 4 over 5.
okay, for the second one.
So we just punch those in as answers. Positive 1 and negative 4 over 5. 1, comma, negative 4 over 5. And now, one more example, number 14. At first glance, number 14 looks dramatically different. Why?
Because it's 1/3.
Yeah, that 1/3. Well, Tim, write up a rule for what a fractional exponent means.
Okay, this is for fractional exponent.
Claim that once you know this, number 14 is easier than number 12.
Okay, I'm going to write two rules. The first one, a number to the 1/2 power is the same thing as the square root of that number. An exponent of 1/2 is just a square root. It's just another way of expressing a square root. Suppose you have an exponent for that little denominator, something other. I don't know why I used it. I should have used an A. It's an A. A to the 1/2 is defined to be the square root of A. An exponent of 1/2 is just a fancy way of saying a square root. And here's the second rule. A to the 1 over n. That's the same thing as saying the nth root of A.
So I'll do number 14.
A fractional exponent is just another way of saying a radical.
So those 1/3 are just a way of writing a cube root. Let me write down that problem.
It's not that bad. We're ending on a lighter note. 3x plus 4 raised to the 1/3 minus 7x plus 1. Minus 1.
Oh, okay. To the 1/3 equals 0. I used to always like this as a test problem because it looks so hard, but it really isn't. Did I write it down right?
Yeah.
Okay.
My advice to you is to rewrite it so that it looks more familiar. Those exponents of 1/3 are the same as what sort of a radical? That number there is a 3. What sort of a radical will we have? Oh, I think he's written it down.
A cube root.
An exponent of 1/3 is the same thing as a cube root.
Before the semester is over, you'll be a master of working with those exponents like that. But once you've rewritten number 14 with the cube root, isn't it going to be sort of like number 12?
But without all the exponents.
Yeah, without all. I think it's going to work out a lot easier than number 12. What do I mean by that? Well, isolate these radicals. I can just move this one over to the right. So I have the cube root of 3x plus 4. Oops, I forgot to write the little cube, didn't I? Equals, moving that over, the cube root. I know this has been a long class. Oh, you keep getting high numbers? I had a student once that told me whenever they get really big numbers, they just punch in the wrong number every time until then you can say similar question and get another. And it still gave you a high number. I'll look at that in a moment. Cube both sides.
Now this is going to get real nice. cubing both sides.
Well, we're
What
going
are
to
we going to have on the left side?
3x plus 4 equals 7x minus 1.
Yeah. It's just a linear equation. Get all the x's on one side and the numbers on the other, however you want to go about it. How would you go about it if you want to get as few negative signs as possible?
Add the 1,
Okay, so
then minus the 3.
yeah, that's good. I like that. Did y'all hear that? Move the 1 over here, so we would just have a 5, 4 plus 1. And then subtracting that 3x, 7x minus 3x is 4x. Y'all see how I did that? Only one thing left to do, divide by what? 4. Okay.
So it's x equals 504.
And do I have to check it? No. Oh gosh. 5 over 4. This is we warned you at the beginning this is going to be a messy assignment, right? I wasn't joking, but pretty much. So anyway, did you get it right? Okay.
Yeah.
So, oh gosh, stop it. What time is it? 4:08. Okay.
Okay, well, hold on. That's it for today.